Hello, sir. Is it okay? आवाज येत नाहीये.
Non-word cut, sir. I think there is some problem.
Yes.
Okay, sorry for interruptions. There was some internet issue at my side. Okay. So let us start with the software, and the software version which I
Yes, sir. Can you share your screen?
oh yes sir, sorry sir. थोडे power supply चा problem झाला सर आमच्याकडे. Okay. Yes. Okay, let us start. So the software version which I am using is MATLAB 2000.
Just hide that one.
Okay.
Okay.
The software version which I am using is MATLAB 2021 2020A, because whichever the command we required or we need for that electric vehicle, those are available only for the version after 2018B. If the person who are working or the person who are interested in this particular field, they should install 2018B and further versions. Okay, so let me share the screen. Yeah, is it visible, sir?
Yes, sir. Yes.
Yes. Okay, so this kind of screen will appear, and inside this software, you can search here also for whatever the help commands are available inside the software, or whichever the some kind of evaluation, study kind of part or study circuit has been given, that you can search over here also by typing, and that will be open. But I would suggest go with the proper way, that is MATLAB and then Simulink. If you can see over here, that's a Simulink command. Start Simulink. This Simulink command will shift ourselves into that simulation workbench, and accordingly we will see. Just click over here. Yeah. So this kind of screen will appear after clicking that command, and there are number of different options to go for Simulink, but you can see here Simulink, then aerospace industry, audio or those kind of communication field, embedded, that is IoT field or electronics field. Everywhere we can use this. Okay, but I am knowing this Simulink related to my work only. So accordingly, I will share. So the best way to go into that Simulink will be with the blank model. Just click on the blank model. Okay. So this is a workbench of Simulink software. Okay, so there are different types of command for this, but there is only one limitation of this. There is no proper GUI given over here. Those who are aware with ANSYS, CATIA, Creo, or any other softwares, they know that proper commands are given, like for circle command, rectangle command. So that kind of commands are given over there. So user can easily identify those command, and that particular person can draw those things. But here, either we need to remember those commands, or we can directly search those commands from this library browser. Okay, so one by one, I will going to tell you. This new for new model, open, save, and print. These are the same solution. The best thing possible, which is possible in this Simulink software, is that let us say you have created your that Simulink model in 2020 or higher version, and you want to open it in a lower version or 2018, or you have created it in 18 and then you want to open it in 20 version. So you have to save with different options. You can see here, save with previous version. So that is the best thing which is given in Simulink. Because if you can see, CATIA V4 model is not open in CATIA V5 model, or R19 model is not open in 21 model. So that is the limitation of those software. But this software is having best suitable option for this. In previous version also, if I am working in 2020, so if I will save it with the previous version 2018 or 19, so person can open in that version. Okay, this is for zooming purpose for the CAD model. This is fit to view, means all the screen will be comprised into a center location. You can see over here, and this is for sample time calculation. Then this is for annotations. uh, this won't be required when we will start with this. And this is for image capturing, etc. Okay, so for clicking over the command, we can go into different passion. Just on this screen, you can click twice, like double click. यहाँ पे अगर double click करते हैं हम, if we will do double click over here, this kind of option will be open. Okay, if you are aware with the command, name of that command or name of that particular block, I will here onwards I will use the name as a block, not as a command, because that will not going to execute here. That block we are going to see open here, and then we will connect it to a circuit, and then we will have to run for some particular time. So let us say if I want to open battery, let us say simple battery, BATTERY. If I will do spelling mistake, battery, so it will not open. So you have to take proper care that spelling should be correct. Let us say the battery. So there are different types of batteries are available here. So it depends on you which type of battery you want to open. Let us say if I want to, I am clicking over here, this kind of simple battery will be open. Now this battery is kind of a conventional symbol of battery, where we are using only positive and negative terminals. So not to use like this. So I will prefer not opening every command by clicking like double click like this. Just try to make habitual with this search command. Okay, browse library. If I click over here, you can see there are number of commands are open over here. So what here there are Simulink commands. There are number of blocks like let us say commonly used block. So when I've done practice size, whenever you will do practice, so whatever the command you have used earlier, let us say 1 month before or 2 months before, all those command will be recorded in commonly used command. Actually, all those Simulink command will start from this continuous. Let us say for continuous block, there is integrator, there is a PID controller, whatever the types of controller we are using, those controllers are being given over here. Then you can see dashboard. Dashboard is for just for measurement of time, measurement of display, measurement of or showing of the graph, etc. It's like a output, for output purpose. It is kind of commands are given here. Then discontinuities. Discontinuities, this kind of symbols are given over here to show what we can say discrete types of graphs. Then the same discrete, to initialize those discrete graph, we need to implement this command like controller. Logic operators are also given over here. Logic and bit operations, like for PLC programming, we can use this particular concept. Then lookup table. This lookup table will show you directly 2D or 3D graph after analyzing or after simulating the circuit. This is very important for electrical vehicles. Then number of math operation also we can do by using this. That also I will tell you one by one. Math operation symbol, like BODMAS example, we can do this all analysis. Divide, then add, then dot product. Everything is given a math function. So you can put some functions accordingly, and then you will get values, square root, etc. Then message events. So there are number of command. I can't tell each and everything. So one by one we will use it and learn about those commands. Okay. So let us say here I want to use a battery. Okay. Same thing I have done. Just not to double click on the screen, I am clicking on this library browser. Click over here and you can just search BAT. You can see command will be displayed battery and just click enter. You will see number of battery commands and battery sorry, you will see number of battery blocks and related other block which can be used for the during creation of that battery circuits. So you can see here data sheet of battery like this, information, battery voltage, battery temperature, like that. So very simple. Very simple command we will see. Yeah. So whichever the by double clicking whichever the battery block we have inputted, that was this one. But you can see whole information is also given over here. You can see here just by moving the cursor at that particular block, you will see total help or kind of information about that block. So if I'm inputting this particular battery, let us say just click and drag and select OK. We can minimize this. Oh, it is not open, I think. Yeah, now. Okay, so this is particular a battery. Okay. One minute. Yeah. So after clicking on this battery, you can see there are this kind of block will be open here. So we can analyze this battery by connect. If you want to analyze a single battery cell, we can put those parameters here. If we will connect these battery cells into number of battery packs or to create a battery pack, and that battery pack voltage and battery pack capacity we can put over here, and then we can analyze. Okay, in we can put all the terminologies here: initial state of charge, battery response time, etc., etc., like that. And as far as the simulation software of MATLAB is concerned, whatever the 3 to 4 types of specific battery which are being currently used in industrial application or in our automobile application, those are given over here. You can see lead acid given here, lithium ion given here, nickel cadmium and nickel metal hydroxide is given here. So we will first evaluate few results with lithium ion battery. So lithium ion battery we have done here. Just we will put values we will put later on. First of all, we will open every command. So let us say battery I have open here. Now we will put a charging circuit, or we will put a we will charge this battery, let us say, and for charging we will need some voltage source. Okay, so let us click over here and click over here voltage source. There are different types of voltage source will be open here. Okay, so we have to yes, you can see over here number of voltage sources are open here. So it is the job of user that which will be the suitable voltage source applicable to that battery. So we'll have to see the connections of that voltage source. So let us say if we will open this D if we will open this AC voltage source first, we will see AC voltage source and try to connect this with this battery. It is not getting connected. It means कि for this type of battery, this voltage source is not suitable. So we'll have to open another. We'll check with this. Yeah, this is open. Okay, this is suitable for this. Okay, so this particular voltage source we will require. So you have to select the proper kind of voltage source for that. Now you can see over here, this particular arrow is given. This arrow will indicate the output, and this positive and negative terminal will indicate input. Okay, so just for appearance point of purpose, we will swap this battery directions. So just click the mouse and rotate and flip. You can see over here, flip the block. We will see left right like this. Okay, so now that arrow has been shown in this direction. Okay, so now let us connect this as to A. Okay, and this to negative terminal like this. So this is a voltage source. You can modify like this.
Hello, sir. Revan, sir.
हा सर,
Yes, yes. Okay.
आवाज येतो ना सर माझा?
येतो येतो. Okay.
But promising parameters are current, voltage, and SOC. Now here only one option is given there, but we need three different parameters. So for that, we have to open three different parameter facility. So for that, we'll have to open that bus selector command. That bus selector will indicate different types of connections. Like many times you have seen that charging connector. We can what we can say, the extension cable. For extension cable is the best example of bus collector. In extension cable, only one pin if we will input to a switch, and there are number of sockets will be given, and in that number of socket we can input our mobile charging and whatever things. Okay, the similar things are here. So I'll just click on the bus selector and click. So this kind of bus selector will be open. Okay, so just click and drag. You can see the information also. This block accepts a bus as input, which can be created from a bus creator. Okay, so bus creator means this particular battery, and bus selector will be a block that defines the output. Okay. Just select. Sorry. Yeah. And you can see over here, still in this bus selector there are only two ports are given, but we need three parameters, so we need to improve these ports also. So just click double this one, and there are selected signals are only two, so just click both the signal which we don't want and delete it. After deleting, we have to drag whatever we required from this table to this table. But right now, there is nothing is displayed in this table because we have not connected that bus selector to bus creator. Okay, so what we will do, we will first connect this to this. Okay, it means that now we have connect this to this battery. So whatever the parameters from this battery will be shown reflecting here. Just अभी click करो. You can see SOC, current and voltage has been displayed. Now I'm deleting this, and I want all these three over here. So you can select one by one, like SOC, select, current, select, voltage, select, or just by control button you can select all and select. Both way you can do, and just apply OK. Okay, so I'll just reduce the length of this circuit. Okay, doesn't matter. Okay, and we can change the size as well. Mouse is not currently working correct. Okay, okay, ठीक है. Now we want to see the results, and for that results, let us say, and for those result, uh, one second. And for those results, let us say we want what happens. For that result, let us say we want another things like values. So if we want only values, we have to open that uh, display block. DIS display. Click. There are two different blocks will be open. First one is a scope and second one is a display. So in scope, you will see only the graphical picturization, and in display, you will see the correct numerical value or correct digital value of that particular instant of time. So let us open both. So scope, and for display, yeah, this one, we'll use this, and let us connect this like this, like this. Okay, this is, let us say, one. We can do copy paste job also here. We can select here like this key to reduce our time by clicking many more times from here. So we just select copy and paste like this. Copy and paste. Okay, now you can drag over here like this. So this one. Let us delete this and let us connect this one like this. Okay. Now we will put our initial parameters here and then we will run accordingly. So the battery cell, let us say initial battery cell we will put over here, that is 3.7 volt, and rated capacity we will assume as whatever the battery cell I have shown you in early morning, that was 25,000 milliampere. So it is 2.5 amperes. Okay, you can see the units over here, and now we are charging the battery. So let us say this is initial state of charge, let us say 10%, and then it will going to charge the batteries again. Battery response time, let us, we will keep 10 seconds. Okay, that so that will be again helpful. So, and apply and okay. Voltage source, voltage is around 100, so let us keep it 12 volt. Okay, we can put any value over here, doesn't matter. Okay, and after this we need to run this particular cycle or particular this circuit. So for running, same here, you can see over here time, time stop time value block is given over here. You can put over here any value. Let us say you want to run this circuit ki baba hey, with the battery of 3.7 volt and 2.5 ampere, how much time it will take. So we don't know that exact time, so we'll have to put any random time over here and we will see how much battery will going to charge at current and the voltage. So let us say I'm putting value 1000 second over here. Okay, in 1000 second what will happen, that we will see. Okay, and just click on the run. Now it is start running. Okay, so can anyone read what error has been shown here? if it is visible to you. Hello, am I audible?
Yes, yes.
हाँ हाँ सर एरर दिसतोय ना इथे.
Oh, this too, sir.
Untitled battery. Okay, okay, thank you. So you can see over here there is a one error has been reflecting error in untitled battery failed to evaluate mask initialization command. I personally involved this error over here because we have created a battery, we have created a circuit, but we have not given command to the software to initialize my electric vehicle, okay, or related to electric vehicle, electric circuit. So just for initialization command, and that initialization, if we will click over here like this, huh, to which to initialize for the battery. So for initializing battery or electric kind of circuit, we need a power GUI command. Okay, so just click on the simulation browser and power GUI. Power GUI, what is exactly power GUI, that we will see. This is power GUI command. You can see here, set simulation type, simulation parameter and preferences. It is like a initialization command for this circuit. So just click and drag over here. You just keep it like continuous. You can change this parameter discrete, continuous to change this graph as well. Okay. So now we will run this program. Simulation 1000 and run. You can see what happens here. Battery is 100% charge. Okay, in how much time? 1000 second. Battery is 100% charge. Okay, then its current is completely current is decreasing completely. It is around minus 268.6. Okay, it goes in negative, and its voltage is 12. Okay, so voltage has been increased. So we will see what will happen if we will revert this connections. Okay, let us delete this. Let us connect positive to negative and negative to positive. What will happen? Okay, earlier we have connected with the parallel kind of thing, and now we will connect with the series kind of thing. Now we will check what will happen. Run. You can see over here battery is not charged. Okay, so for single battery, and if we are connecting like this, so we'll have to connect it in positive to positive and negative to negative like this. Simulation. So we will increase that voltage up to somewhat. Let us say 40 volt. Apply. Okay. Again we'll run. Current is continuously increasing. It means we need to reduce the voltage. Let us keep it as 5 because battery voltage is itself 3.7. Yeah. So it is like this. Okay, so whatever the voltage we will give from here, the same will be reflecting over here, but current will going to be reduced and battery will 100% charge. We can again see what will happen with 4 or whatever the battery voltage 3.7. Let us keep 3.7. Okay, so 3.7 is not sufficient. We need minimum 4. Yeah, you can see for 4 DC voltage source, if it is a 4 volt, battery will charge for 35.92% for 1000 second, and current will be like this, and this will be. So it means ki we need amplitude, voltage, minimum 5 of DC source, so that we need to improve or we need to charge that battery 100% in 1000 seconds. Are you getting my point? Hello, candidates?
Yes, sir.
So in this way, we can do number of solution, number of possible simulations. But let us assume that this software you don't have, then this kind of experimental work you have to do actually offline or physically. In those cases, there will be a tremendous increase in time, and definitely it will be a hectic work. Now we will see the graphical representation of this. Now, just check out the graphs. Click on this scope block. Click like this. You will see this kind of graphical picturization from it. Okay, now there are number of settings how to give this black appearance at white, this yellow line with the blue. There are number of settings over there, but that is not a part of our interest. You can see over here, battery from initially it has charged within how much second? Around 360 or 370 second, and then it is continuous 100% after that second. Okay, so it means ki we can run this for 100 sorry we can run this system for 400 seconds also. Okay, so from this graphical presentation we can see within 400 second with 5 volt, a 3.7 volt battery is recharged. Okay, that can be a conclusion drawn over here. uh, Now look at some setting. Click this paint block styles, field color, you can see white, axis color you can keep it black, and label color you can play a hey whatever you want. Okay, see, apply. So that kind of appearance will be here. So let us keep it like let us keep it white, let us keep it white, apply. Okay, still, and let us keep it blue. Okay, so in this way we can see the appearance for printing or graphical presentation. Okay, or we can change again some modification over here, axis color black, like this. So we need this white, this is black, apply. So let us do apply. So this will be a better setting. Figure color white, axis color white, and this command ticks and like this. Those are blue, and this is also blue. And just apply. From this you can increase thickness also like this. Apply. Okay, this is a graph generated. Okay, this setting you need to do only once. Okay, and here again you can run the setting. Okay, like this. Here you can change the labels also. Here your label as given as only SOC. So in this sorry, from this setting, the same one here, display. In this display you can put label. So we can say battery state of charge, like this. Apply. Okay, so you can see like this table. And this y-axis, this is the battery percentage. On x-axis, this is the time. Okay, let us check with current. See the graph of current. It was continuously increasing up to this much value, and then it is continuously increasing in inclined way, and it is moving on increasing in decline way. And this graph is continuously
Hello, sir.
Hello, Ravi sir.
Sir, you are not audible.
Okay, sir has left the meeting. Sir will join again.
Yes, sir.
Maybe there might be some network issue related to this. So he will join again and will deliver the lecture.
Okay, am I audible, sir?
Yes,
Yes,
sir.
yes.
Yes.
Okay.
Just share your screen, sir.
Sorry, there was some internet issues going on continuously. Let me share the screen again. Yes. Is it visible now, sir?
Yes, sir.
Yes, sir, yes.
Okay. Okay. I'm repeating whatever I have done before 2 to 3 minutes. So now we will apply resistive load over here, and for that resistive load just click on the browser and select RLC, so that all three different types of load we can input, but not going for all three different load. Let us keep any one. So series RLC branch I have open over here, and in this series RLC branch, this series RLC branch, let us double click, and after double click, am I audible, sir?
Yes, sir.
Yes, sir, yes, okay. In this, double click and select R only. So we will select resistive load. Let us keep it as 10 ohm, or we can keep value anything. Apply and OK. Now we will connect this into this circuit like this. Now we will run this for discharging the battery. So for that, we need to change this parameter. So let us assume battery is 100% charge and battery response time is 10 seconds. That we will assume. Okay. Because now this will be earlier whatever we had done, that was for charging circuit. Now we will do it for discharging circuit. So apply. Okay. And same time we will run. Battery is still 100%. Okay, so we need to increase the load as well. So let us say 50 ohm we had done. Apply. Okay, battery is still the same. let us 200 resistance. Mm, what happens here? Yeah. Let us try to improve this value. Battery is 100. Same. Let us make it 500. We can increase the time as well. Okay. So resistive load is not sufficient. So we will have to change this load again. So let us take series RLC load and see what will happen from this. Same here, nominal voltage, axial, and everything will be same. And parameter nominal voltage frequency we will put as 0. Apply here. Sorry, sorry, frequency. Let us keep it 60. This let us keep it as 0. Inductive and capacitance. Apply. Okay. So now this will be a resistive load. Let's check what will happen with this. Now we will run it. Yeah. So it means ki battery is not getting discharged at the same time with this resistive load. So this resistive load we need to increase further again, and then it can move for further values. Okay. So we will check the values again over here. Yeah, it is completely straight. Current, it is continuously increasing like this, and this is voltage. Let me show you different example for discharging. Yeah, same work I have done. I have not changed. 12 resistance ohm. Battery capacity I have increased. So let us say we'll keep at the same 3.7 and 2.5, and like this. Apply. Okay. Now we will run it for, let us say, 1000 seconds. Yes, this is now correct. Okay, that was also not wrong, but 1 second. Let me check whether I'm audible. Yeah, net is corrected. Yeah, this is also correct. Yeah, this is the same thing has been given over here. So we will change this value of resistance again here. Let us say 50. Apply. Okay. Run. What will happen? Battery is showing such a kind of values. Maybe this is because of the mechanism which is being given in this MATLAB. 12 ohm battery, and we'll need to increase this battery voltage. Let us say 11.1. We'll check what will happen. This has gone to 88 and like that. Okay, so if you will see this graph, it is decreasing like this continuously. This graph for current, it is in what we can say exponentially it is decreasing, and voltage is also the same way. Okay, so now whatever the result we have seen now, it has for lithium ion battery. Let us check this for other types of battery, what will happen. So let us keep it lead acid battery. Let us put nominal voltage as 12, 11, 11.1 rated capacity, let us keep it as 20 ampere, and initial state of charge 100. Apply. Okay. Run. You can see it battery SOC is much more than a lithium ion battery earlier, because in earlier the current capacity of lithium ion battery we have taken as 2.5, but here we have taken that current capacity as 20. So if we that is a drawback of lead acid battery, that to meet the same state of charge of lithium ion battery, current capacity should be much, or I'll say much more than that lithium ion battery. So that is major disadvantage of this lead acid battery. You can see the same graph here. Graphical picturization will be same. It is also exponentially decreasing. Voltage also exponentially decreasing. In the same way we can do that. Okay. In the same way we can do other possible calculations, like lead acid, then let us say nickel cadmium. What will happen? Apply. For nickel cadmium we will take the same parameter and run it. Nickel cadmium, okay, 1. Okay, so you can see lead acid and nickel cadmium are showing the same result, but current and voltage are slightly changes. See, now it is not exponentially, it is somewhat exponential till this point only, and then it is continuously a linear, non-linear, what we can say, relation has been followed over there. Here also the same thing. We'll check now this with nickel metal hydride battery. Same parameter we will put, apply, okay, run for the same time. See, so nickel metal hydride and which one, third battery, the earlier, those are showing the same result like this. So let us check this one, the same, and this is the same. So we can predict one conclusion, that nickel cadmium and nickel metal hydride battery are near about similar or same ratio or same relation, whereas lead acid battery is quite hectic, or what we can say, consuming, or we need to consume more current from it. With the same, for same parameter we will go for lithium ion. Let us check what happened. You can see. So among all lithium, this is not exponential, this is somewhat a smoother operation. So we can see lithium ion battery is a suitable solution for this. Okay. So everyone got some idea, somewhat. It is not kind of a software which can be learned in the first lecture, but got some idea.
Yes, sir. Sir, it is practical in real use, in practical use.
Yes, sir, definitely. Because we can, what we can do, let us say ki for particular application, you want to select a kind of battery. Now, don't think for heavier or much heavier application or mass application. Let us assume there is a toy or your household toy is there for your younger brother, you want to purchase, and you want to run it using some electrical battery, or like this battery. So which battery should have been chosen for that running the vehicle, that you can select. Now this is for a small application which we are using for our day-to-day life uses. The same application, if you will go in industry as a EV engineer, let us say electrical vehicle engineer, so that time it is not your task or your work to assemble all battery to that vehicle. It is, what is your task? You have to suggest a suitable type of battery and suitable type of battery connection for that particular vehicle. If the organization where you are working, there you have gone, and they are like a small scales company, they are not affordable for lithium ion battery, so you can suggest them ki, what lithium ion battery and nickel cadmium battery are giving near about similar results. So you can go for it, because compared to lithium ion battery, nickel cadmium battery are somewhat cheaper, not much cheaper. Okay, not much cheaper, but you can suggest them. That is,
Sir, but lithium cadmium battery has a problem that when cadmium go in water, it causes bone cancer.
yes, definitely. Problem is with every battery. That doesn't matter. Cadmium is, yes, definitely. Cadmium is creating number of problems. That's why many industrial application or many automobile sector are diverting towards either lithium ion battery or whichever the battery, which morning we are suggested, aluminum or sodium batteries. That's why. But that can be your suggestion. I am not saying go for nickel cadmium or nickel bromide or those kind of battery. But those batteries are available here. That's why we have done the simulation. Let us say there are another different software which are being used by ARAI. I don't know the correct name of that software. It is started from some D word. So in that there are number of different types of batteries are available, so you can choose them. Then you can compare, you can do a comparative analysis ki nickel cadmium is somewhat dangerous for human health, and is it hazardous for environment applications also. So we have to choose bad from the worst. Okay, actually all batteries are bad actually, if we can see as the human health point of view. So we are choosing not to go for nickel cadmium, then we can go for nickel bromide also as well, and then lithium ion battery as well. This is
And sir, what about lithium phosphate battery?
lithium phosphate battery, that also we can use, but that we that is right now this, it is a restriction for this software, that battery is not available here. So we can run that battery over here also, or there is another software. If you will purchase license version of this software, then you can inbuild that another phosphate battery or another different types of battery in the software, then you can do the analysis or simulation for the same thing.
Sir, in this software, whether practical losses, what losses are there, this has been considered in this software.
Which losses, sir?
Now, whatever this connection transmission losses are there, or some quality of material depends upon also quality of material.
No, those losses are not reflecting here. Here we can see the actual model of vehicle. Let us say tomorrow, in tomorrow's session, I will show you the complete electrical vehicle, how complete electrical vehicle will be structured here. It is just a software for simulation, sir.
Yes.
Let us say driver. So for driver, there will be only a driver block will be given over here. You have to give initial parameter and you have to just run it. You will not get correct result, but you will get some approximate result. But whatever you are saying, that losses and then electricity losses or transportation losses, those are not reflecting here.
Okay, okay.
So this was a simple circuit. Further we will go for different types of connections as well. Okay, ki how series, if we will connect it in series, what will happen? If we will connect it in parallel, what will happen? That will also see here. Okay, one of the fellow was asking some questions. Hello. Yeah. Okay, so let us stop for this. This is charging and discharging circuit. Now we will start with battery DC parameter circuits, and then battery charging and battery connections. Okay, Kathade sir, as you said that these practicals are involved in that honor course syllabus also. There we can do this. Okay.
Okay, okay.
Okay. Is there any student here who has chosen that honor course as EV?
Yes, sir. I.
Yes, sir.
From which college you are?
Sir, KBT College of Engineering, Nasik.
Nasik. Okay.
Sir, College of Engineering, Vadgaon, Pune.
Which college?
Siahat College of
Yeah,
Engineering.
good. Okay, okay, from the same institute. Okay, we will see. So, in this way, you can do the analysis. In this way, you can do the simulation as well. If you are planning to do masters or higher educations in the same field, so if you will get a knowledge of this software, not necessarily this software will be used in industry, because this is a user-friendly software. That's why we are using this. But the same software, if you will get the knowledge of this software, you can use it the same concept for other another softwares as well. Okay, but here we are not getting actual thing. Here we are getting just a simulated thing only. Okay, so let us do for another circuit, like which one is that? Charging, sorry, connections, battery connections. Okay, so that I will show you here. So let us delete this. Let me delete this. Yeah. Yeah, that much. Okay. This is a PPT which I am showing. Okay, same Simulink. So because of less time, what we will do, ki whatever the circuit I have drawn earlier, that I will open here. Whatever the circuit I have earlier drawn, that I will open here. I'll whatever the doubts related to that thing, that we will discuss, and then accordingly we will run that circuit. Because if we will connect each and every parameter over here, then it will take some time, and all of you guys don't have that software, so that will be difficult for things. Okay, or as per your opinion, shall I go for one bringing each and every block and then connect in front of you, or shall I show you directly that circuit, and then we will discuss the circuit accordingly? हा सर, कसं करायचं कठाडे सर?
No, sir. What whichever you feel convenient or
No, I am convenient with it. I am convenient with
you
both.
feel beneficial for students or faculties. Which?
Yes, sir. Yes, sir. Because what I am thinking ki to we will give to, today's one day for students. They will install that software at their end, and then accordingly will start those things.
Right, right,
That will be again good for them.
right.
Okay. So let us open. Let me open that soft model. Yeah. There is nothing different in this circuit. Okay, everything is same. One by one block I am going to tell you and dictate you. Okay, see, these are the battery that everyone is aware. Okay, I'm audible, guys? Hello, sir?
Yes, you audible.
Yes, yes.
Yes, yes, yes.
These are the batteries which we have seen in earlier charging circuit, and we will discuss this connection later on. This is a voltage sensor, okay, to measure the voltage. Okay, you can see over here, this is a voltage sensor. Okay, voltage measurement. How you can bring it over here? Just click over here, voltage source or voltage, no, sorry, through voltage source we can get that voltage source, voltage sensor. Okay, if you will select voltage sensor, you can see number of voltage sensors are will be open here. So whichever you want, according to that you have to open it. Okay, uh, if you that voltage sensor won't be connect, so you can go for voltage measurement as well. See, but in under voltage measurement it will not open, so voltage sensor, that will be a suitable command. Okay, so the same voltage source I have been drag over here, and the same I have just flipped it, and accordingly I have used. Okay, so right now I am cutting this. Yeah, this is the same scope block, this is the same display block. Next, this is a current sensor. This is a current measurement device, or sorry, this is a scope. This is current measurement device. Okay, so this is current measurement device here, because here we are doing this circuit connection for battery pack. Okay, battery pack in the sense ki the same circuit you can do for only 2 battery cells, but here I have done with 3 battery cells. Okay, you can do it with 2 or 3 or 4, 5, 6, 7, 8, whatever the number of battery cells you have used for making a battery pack. Okay, so using this battery pack, whatever the bus collection is given here, bus selector, whatever the bus selector given over here, that bus selector will show only the parameters related to single battery. Okay, but after making a battery pack, complete a battery pack, whatever the result we want, that will be for only one current, only one voltage. So for that, we are using this sensor, voltage sensor and current sensor. ठीक है? हाँ, only new this is also aware. This is just a display devices. This is also scope devices. This 3 scope and 3 display devices are for the single batteries, and this scope and these display devices are for battery pack connections, and this one for current. Okay, only one thing is given here. This is diode. Okay, you can see your IGBT diode. Now this is somewhat electronic related part, but that doesn't matter. We need to learn only what is its use in our circuit. So just click on here. We'll see what is IGBT meaning. IGBT diode. Okay, so IGBT, it is a device in parallel with series RC circuit or model that has internal resistance. Okay, if this IGBT will act as a switch. Okay, to turn off or turn on the system. Like this IGBT will be used in battery management system. So I have prepared one lab manual. In that lab manual, you will see, or if you will Google on that, what is the appearance of battery management system. So it is like a microcontroller. In that microcontroller, you will see that IGBT diode. Okay, so this IGBT is actually a diode which will be act as a controller for controlling the overcharging or what we can say thermal runaway of the system. Now, how it will going to work? This is a conditional block. Okay, conditional block in the sense कि if that battery pack SOC will go beyond a certain limit, or that state of charge is reach up to 100%, this will be 0. If it will, this is a constant block. This 0 will show that battery is 100% charged. You need not to do further charging, or this diode if will control the further charging. Okay, and if it is 1, it needs there is a need of charging. Okay, so it means this diode we are implementing here to control the charging and extra or overcharging effect on the battery pack. Okay, now we will see this battery connection. Here you can see the positive terminal are connected with the negative terminal of the battery. Here, second, the positive terminal are connected with the negative terminal of battery. Can anyone tell me which will be the connection, series or parallel? Which will be this one, series or parallel? Yes, anyone from student? When I am connecting positive to negative, which will be the connection? It is series or parallel?
Series.
Yes, it is series. It means now we will see the battery parameters over here. So battery parameter which I have kept here is a nominal voltage 4.2, rated capacity 2.6. You can change this whatever you want. Only the concern is that you should have around minimum 8 GB RAM system, and Intel i3 and further processor, and that C storage, that capacity, or that C drive capacity should be more than 100 GB. Okay, then and only then this kind of running will be smoothly. Otherwise, it will take much time. If you will go, if you will work with the 4 GB RAM and C drive with only 30 or 40 GB, it will be somewhat slow. It will give you result, but it will be a slower. Okay, so this parameter I have given here: 4.2, 2.6 rated capacity and initial state of charge, like this. Now I will run this. So when I will run, how I will confirm whether my software is correct or wrong? Oh, sorry, this is a load. Okay, so load I have kept here like series RLC branch. Load I have given as 4.4 ohm only. Okay, we can change this also. We'll check the result. See, now how to verify whether my connections are correct or wrong? So 4.2 is battery voltage of first. So when I will connect it in series, so and there are 3 batteries, so when I will see this voltage here, that should be multiplied with the 3. So 42 multiplied by 3, that should be the answer. 12 if I will get 12.6 over here, it means that my connections are correct and I have connected it in series. If the voltage will be same, it means that there are connection problems. And if current will increase, still there will be a connection problem. Current of this battery, current of this sensor should be same, or I will say must be same. Then and only then your circuit is correct. It means when it is in series, only voltage should increase. Yes, I am audible. Okay, now we will run it for around 1000 seconds or 15 seconds or 2500 seconds. Now the basic thing, those who are working on this field, for them I am telling you why I am taking stop time every time that it is 2500. This is because when we are doing that practical work, so whichever the company, whichever the organization or R&D institutes, they have finalized that they have finalized few types of cycle. If you are aware with FTP cycle or drive cycle, have you heard the name drive cycle? Okay, so according to that drive cycle, we have to identify this. So many scientists have found out that some drive cycle, and if whatever the graph we will generate that will meet that drive cycle, then it will be a correct answer. So normally those drive cycle are run for 2474 seconds, 2474 seconds. That's why whenever you will run your simulation, take minimum time as 2500. Okay, if for 2500 it will be run, then it will be a correct circuit. Now we will run it. Start. You can see over here. What is the state of charge? It is right now 19.68. This is for single battery. Okay, 19.68 for single battery, 2.889 current for single battery, 4.238 volt for single battery. Okay, now you can see this 12.71. So 4.238 multiplied by 3, how much it will be? 4.238 multiplied by 3, it is 12.71. It means that whatever this voltage is given here, it has been multiplied by 3. It means our answer is correct, or our circuit is correct actually. And current whatever displaying here 2.889, the same has been reflecting over here 2.889. Understood the concept? Okay.
Yes, sir.
So yeah, thank you. So the most important thing for running the circuit, you have to put initialization command as power GUI. Okay, except that power GUI command, you circuit won't be run further. Okay, and for getting more than one parameter, you have to select this. Right now, by default, only three parameters has been given for the battery, like SOC, current, and voltage. As I told you, with the license version, you can increase those parameters also, like state of health, you can calculate. Then state of safety, you can calculate in some percentage. Current variation, voltage variation, number of parameter we can input. Okay, so this is for battery circuit connection in series. Now we will open it for parallel. Same circuit, nothing is different. Okay, only you can see the connections: positive connected to positive, positive connected to positive, negative to negative, negative to negative. That only the difference is there. Okay, remaining circuit is same. Now we will run this for 2500 seconds. Let us change this battery parameters, because whichever we have taken at early morning, that XTT company 3.7, let us say rated capacity. Okay, let us say rated capacity as 2.5. Initial set of charge 100. Battery response time, let us, you can put any value, 1 second, 0 second. Let us take at 10 second. Apply. Okay. And let us run it. Now you can see voltage is same. Is it visible? Hello, sir?
Yes, sir. Yes.
Yes, sir, visible.
You can see voltage is same. Here for current is 0.0114. So if we will multiply it with 3, you can see whatever the value. No, I think we are getting wrong. Current is not multiplied. That current should be yeah, that current should have been changed over here. Okay, there is something wrong in my. I done some mistake over here. Yeah, let me check the connection. Connections are correct. Connections are correct. Why it is happens? Yeah. 1 second. Can anyone tell me what mistake I have done? कोई बता सकेगा? At early morning session, I had told you that whenever we are making a battery pack, we have to select battery cells with similar parameters. What I did, I had changed the parameters of this cell, but other cells are same. That's why that mistake was done there. Now we will get the correct results. Yeah. Now you can see. Is it visible now? Hello?
Yes, sir. Yes.
Yes. You can see here, current voltage is same, 4.003 and 4.003 over here also. And the same current capacity, 0.3032, it has been tripled over here. So let us check 0.3032 multiplied by 3. It is correct, 0.9096. So we are getting the correct answer. Understood, everyone? What exactly the system of series connection and parallel connection. So in battery pack formation, you can the other student or the persons who are attending this session, they are try to this to make connect two battery connection with series and these two battery connections with parallel. and try to evaluate the result, what will happen exactly there. Okay, so that can be a good task for you. Okay. Yeah, and those students who are attending my session right now, for them, I just want to share one thing, that whatever the circuit I'm showing right now over here, this the industrial persons or the industrial experts are charging for this kind of circuits. If you will go or if you will search on YouTube's, this circuit is payable for 1200. Okay, but if you will do at your home within 30 or 40 minutes, you can draw this circuit. Okay, so this is very simple circuit, still it is having a cost of 1200. So you can imagine ki, if you will have a good practice on making this kind of circuits according to the customer requirement at your home, you can earn huge amount of money. Okay, what you need to do, only you have to clear your mechanism, you have to clear your basic or logic, ki when I have to connect which kind of point and terminals, only those things. Okay, so this is just for your earning and that kind of efficient purpose, that's why I'm telling you. Okay, so now next we will, if any student or any person want to ask something, then we will discuss. Otherwise, we will move ahead. Any question from anyone side? Actually, session is not ended. I'm just giving 5 minute break, like for questions and answers. Otherwise, we will continue with that DC motor circuit as well. Any question from anyone? Okay, doesn't matter. Thank you. We'll go for another circuit. Okay, let us check the graphical representation of this, and then we will see another circuit. Okay, see the graphical representation through these blocks. What will happen? Yeah, you can see linearly it is going to be decreased. Let us keep it at stop. Okay. Yeah, there is kind of a step is being started. You can see from zero, this line is going like this one, and there is a step response you can see. Okay, if this step response you want it in intervals, you have to either increase the battery parameters or that battery connections. We'll check with the voltage. Yeah, it is decreasing continuously, smooth. Okay, let us check with the current. It is also having the step response like this. Okay, so in this way you can analyze many circuits as well. Let us run this for more second, 10,000 seconds. What will happen? We will check. No, it will take much time. Let me stop this. Because we want to change, we want to check this conditional parameter, whether we will get 1 over here. That's why I'm running this. No, because until and unless that battery will going to be discharged, that won't be 1. Okay, so try to do this practice at your home, whoever are interested person for this. Till then, let me open that motor. Yeah, this is for BLDC motor. Let us open a simpler one. ये थोड़ा difficult हो जाएगा. Charging, discharging, cell balancing. Yeah, regenerative braking. That will be a suitable one. Yeah. This has been created by one of my friend. So in this way, you can generate a label or a kind of nomenclature, or what we can see like this. And you can see here number of diodes are given over here. Same thing has been given over here also as well. This is a diode, same diode, but only some parameters has been changed. Okay, this is for electrical kind of work. So if I'll run for this, we can see the graphical representation. Because all are, I think all are related to mechanical field for today's session. So they maybe not, they won't be aware with this parameters, armature, what is exactly armature current, field current, etc. Uh, as I told you in the morning session that there will be a concept of regenerative braking, which is difficult in IC engine based vehicles. So regenerative braking are most suitable for electrical vehicles. So for that regenerative braking, we need to learn this motor parameters, and accordingly for the same thing, this particular circuit will be useful for it. It taking much time because I have only 8 GB RAM computer. That's why. But with more suitable configuration and better configuration, you can increase the speed as well. Let us wait for 2 minutes. Maximum in 2 minutes it will be complete. You can see here time cycle 294, 300 second has been completed. Okay, I don't think there will be any changes later on. after this 500. So you can see during this graphical presentation, armature current of that DC motor is increasing like this at with a steady response, and field current is going to be decreased like the steady response, and there is a step response from we are getting. Okay, only in this case there is a some small curvature which is deviation that we need to improve on that particular thing. Okay. Okay, so let me stop this. Okay, and using these blocks we can find out the results. There's armature, electrical torque, armature current, field current, and etc. And those same values are being given here. In this case, not to distinguish every parameter differently, all results has been given in one block, display block, and all result have been given in one scope block. That is only difference between here. In this way, you can evaluate the result of other parameters as well. Let us say here, let us take this example. Here, I have taken 3 battery cells. Okay, so instead taking 3 battery cells, let us take 1 battery and 1 supercapacitor and connect those battery and supercapacitor and verify the result. What will happen with the hybridization of battery and supercapacitor? Try to evaluate those results. In the same way, supercapacitor is also given over here. Look at here. Just click super capacitor. I think I have done the spelling mistake. Yeah, you can see like the same way as a battery, the super capacitor is also here. Yeah. So in the same way, you can connect this and try to verify the result. Okay. So that can be a good. Let us now. We'll do it. Okay. Let us check what will happen. Let us modify the parameters of this capacitance. It is 100. Assume it 100% charge. Voltage is much more, so let us keep it as 5 volt. And this capacitance measures in farad. Okay, number of capacitors only one, and parallel capacitor there is no. Okay, let us apply and okay. Let us try to run this simulation. What will happen? Okay.
Abhijit Shelar, mute yourself.
Okay. We can see the changes over here. This current, voltage has been summed up because of this supercapacitor, and current is nearly same. Voltage is summed up here. Voltage, you can see only 2 battery connection voltage has been seen over here, but what it shows, voltage is decreased because of implementation of supercapacitor. It means ki the pressure or the torque requirement from that vehicle that we can reduce and we can increase the efficiency. That is the first thing. Many students may get confused that what is ultra capacitor and what is super capacitor. So both are same term. Both are being used by different company. That's why some company will use ultra, some company will use super. Okay, both are actually same. In this software, that same capacitor has been given as a super capacitor. In many term books or in many authors, they have used as ultra. Okay, so there won't be much difference between those things. Actually, if we will go for the difference, super capacitor are measured in farad, whereas ultra capacitor are measured in coulombs. Okay, that's the only one difference. But that coulomb can be coulomb as is also unit of capacitance, and Farad is also unit of capacitance. So both are same terminology actually, if you will see. Okay, and according to now try to do one more super capacitor is here. What let us check what will happen, and try to do further analysis. So that will be good practice for you guys. And it's a request from my side that if you really want to interest or really want to do something like this, so try to install that MATLAB software today if you can possible that at your end, and we will model complete electrical vehicle tomorrow. Okay, complete electrical vehicle in the sense ki simultaneously one by one, whatever the command I will take, you will take that command, you will choose that block, and we will do that thing. Because today I just imported those CAD that FE sorry Simulink model which were earlier I had done, and then I have implemented here, and then I have shown you. But I think as a practical purpose that is not a suitable thing to show as a hands-on. Okay, so as the meaning of hands-on is ki simultaneously we'll have to work at the both from the both end, then we can work better. Okay, so for today's session, that's it from my side. If you have any question, if you have any further suggestion for me as well, if you have any doubt, you can ask me, and we are free for question answer sessions now. Any question related to your syllabus, any question related to research work, any question related to your masters in electrical vehicle, whatever, or those faculty who are attending right now and want to pursue their research work or PhD in the same field. So if I can give some good suggestion to them, that I will be fortunate for that, if you will feel like that. Okay, so Katade sir.
येस सर येस
हा सर आतापुरतं तरी एवढं ठीक आहे, कारण ते सॉफ्टवेअर मुलांनी जर इन्स्टॉल केलं त्यांच्या साईडला किंवा आपले जे पार्टिसिपंट्स आहेत, तर मला अजून ते चांगल्या प्रकारे सांगता येईल एक सर्किट, आणि एक पूर्ण प्रॉपर इलेक्ट्रिकल व्हेकलचं सर्किट आपण त्या उद्या तयार करून घेऊ, म्हणजे जेणेकरून मुलांना सगळ्यांना ते सिम्युलेशन पद्धतशीर समजेल. म्हणजे जे मुलं
सॉफ्टवेअर सर त्यांना कसं म्हणजे
नाही ते डायरेक्टली युट्यूबवर सर्च केलं त्यांना तरी पण मिळेल, कारण लायसन्स व्हर्जन ऍक्च्युली माझ्याकडे पण नाहीये. तर युट्यूब मी सुद्धा युट्यूबवरूनच ते लिंक वगैरे बघून ते डाउनलोड केलेलं आहे.
मग कुठलं मॉड्यूल किंवा पर्टिक्युलर कुठलं ह्याच्या रिलेटेड?
चालेल 2018 बी च्या पुढचं.
2018 मेच्या पुढचं.
2018 बी दोन व्हर्जन येतात, ए आणि बी. तर 2018 बी च्या पुढचा असला पाहिजे, कारण त्याच्यामध्येच ड्रायव्हर लिंक, त्याच्यानंतर त्या ड्रायव्हरशी रिलेटेड ज्या कमांड्स वगैरे लागतात, टायर वगैरे किंवा त्याचे रेअर व्हील वगैरे, ते सगळे त्याच्यामध्येच आहेत.
ओके ओके. सो ऑल ऑफ यू जस्ट take a note,
or if you want I can share that link to sir, and sir will share that link into that WhatsApp group, and
right.
Those who want actually they can do those things. And two of the student who has asked me question before some time, so actually their in honor course their practical are going to be conducted using the same software, I think. It is request to my all faculties also, those who are involving in teaching this subject, they should get familiar with this software. That will be helpful for their growth as well, because this is the most user friendly and suitable software for which can be understood by we people just by taking a YouTube links.
Right. If anybody has any doubt regarding electric vehicle or this particularly this software, you may ask now. one is asking, sir, please share the recordings. Definitely, we will share it on our WhatsApp group also. Sir, is there any? There is no any issue, no? Sir?
No, for my side, there is no issue. Even if anyone is really interested for this kind of work, I'll ready to share these models also for them. Actually, it has cost of around 1200 or more than that. But as a student point of view, if any student is there or if any faculty who are eagerly want to work for this, I'll give them to this circuit on a free of cost, no matter from my side.
Okay, okay. Thank you, sir. Thank you very much.
Yes, sir, definitely, sir. But that request should be from their side, na sir. We are just discussing, but if no one will interest and we are just giving them like, so that won't be a good practice. So let us.
One has requested. That's
Yeah,
why.
yeah, definitely, sir.
Okay.
I would I would also request that share my contact number also. Ki if anyone want further help, because while teaching we can learn more and more things. Teaching is a good practice for learning.
Right.
Yeah.
So in this software, where tomorrow weather will Simulink total vehicle, electric vehicle simulation will be there, no?
Yes, sir. Total electric vehicle we will manufacture tomorrow, and the same circuit can be applicable for two-wheeler, four-wheeler, and everything, every kind of vehicle. It is not only that circuit will be applicable for only two-wheeler or four-wheeler. Only we have to remove those two wheels from that circuit,
Right.
and that will be the same circuit will be applicable for two wheeler, and if we will implement those two wheels again, that will be applicable for four wheeler as well.
Whether animations are possible in this?
Animation, actually, what exactly you want to ask? Animation means?
Canvas means whether
No, sir. In this, these are the circuit of completion of blocks. If you are aware about that mechatronics subject, in that mechatronics we draw block diagrams.
right,
Okay.
right.
So the similar kind of circuit will be for electric vehicle. Don't think like that. If we are drawing electric vehicle tomorrow for simulation,
Right.
you won't see a kind of four wheeler there. There will be a kind of rectangular block which will show driver, and there will be a circular block which will see tires, and we will just going to connect, and we have to assume it is a four wheeler, and then we will going to show some kind of driver circuit, driver is seated like this, and then we will evaluate the result. We will implement gear.
You will get some performance.
Yes, performance result we will get.
Result will get, right.
We will not going to see. If you want to see that kind of simulation, whatever you want to see like animation like that. So for that we'll have to go for FEA, and in FEA there is a battery module is given.
Okay, okay.
Separately. Like for structure analysis, there is different concept. For CFD analysis, there is a fluent is there, but in FEA, in under that fluent, there is a battery module, and under that battery module, there are three different battery modules are available. But that is available after 2018 and further version of ANSYS. So there you can just create that model and import that model and just apply the forces and run that model. You will get animation also. But it will be very hectic. It will need around 16 GB RAM PC minimum for smoother running operation.
Okay, okay.
Yeah.
But tomorrow's hands-on session will be more interesting.
Yes, sir, definitely. For that, I'll definitely send that software link to you to share it in a group, and that will be again better.
Okay, okay. Very right, sir.
Yes, sir.
Okay. If any student want, may I ask now if doubts, or then now shall we conclude, sir? If there is no doubts.
Yes. If there are no doubts or no question from anyone's side, we'll stop. Only one fellow, that Adil Sheikh, has asked one question that he want a recording. I don't have any problem for that recording. Definitely, you can share those recording to him also.
Okay, all dear participants, feedback link is shared in a chat box. You can fill it and submit it. You need to submit the feedback link for all sessions. Then only you will be eligible for the certificates. Right. So today, this afternoon session, sir has taken a very hands-on session on a MATLAB Simulink model and explained the basic how to build the basic circuits in the MATLAB. And tomorrow is going to build all the total circuit for any electric vehicle. Definitely he will share the my software link with me, and I will definitely share it with you also. So tomorrow you be ready with installed the software in your PC or laptops, and or even in mobile, and will take simultaneous hands-on practice. Thank you, sir. Thank you very
Thank
much
you very
for
much, sir.
this
Thank you.
wonderful session. Thank
Thank
you
you very
very
much, sir.
much. So I announce today's session is ended here. Thanks
Yes.
all. Thanks to all for joining.
Thank you. Thank you very much, sir.
Okay, all are requested to leave the session. We'll be meeting tomorrow with the same speaker. Kathare, sir.
Yes, yes.
Shall I stop recording?
Yeah, yes, sir. Sure.